Section 9.3, distributions needed for hypothesis testing. So here's where we're going to get into some of this stuff. First, when we do hypothesis testing for a population mean, two possible situations can occur. And we talked about these back in chapter 8. We didn't cover section 8.1 too detailedly, but here's our two options. Number one, the population standard deviation, sigma, may be known. And in this case, we would use a z-test. If you know the standard deviation for the population, you would use a z-test. The information that you would need in order to do the hypothesis test would be that sigma value that you know, the sample mean, x bar. You need the sample size to be greater than or equal to 30. And then you would need your z-score. And remember, that means that the definition of our z-score is that x minus mu divided by sigma gives us our z-score. We also have our tables and our calculator where sometimes we calculate those z-scores based on areas and proportions. The next possible situation, and probably more likely with our population mean, is that we would have the standard deviation for the population is unknown. And in this case, we would use a t-test. And our information that we would need here, we'll need, instead of the population standard deviation, we will need the sample standard deviation, S. We will still need the sample mean, x bar. The sample size still has to be greater than or equal to 30. And then we have that additional criteria that your sample size should not be more than 5% of your population size. And then we use our t-score, which is x bar minus mu divided by S over the square root of n. So that is our t-score. And again, that's when we do not know the population standard deviation, so we use the sample standard deviation instead. The third type of hypothesis testing that we're going to start out working with is for population proportions. And in this case, we use a z-test. The information needed is the sample proportion, p hat, which is x divided by n, the number of items with the characteristic divided by the sample size. We also need to know the mean of the sampling distribution and the standard deviation of the population sample proportion. And so we have sigma of the sample. Sigma of p hat is, remember, p times 1 minus p divided by n, and we take the square root of that whole thing. Again, the requirements for estimating a population proportion, n has to be less than or equal to 5%. Lowercase n has to be less than or equal to 5% of uppercase n, so the sample size cannot be more than 5% of the population size. We also need n times p times 1 minus p to be greater than or equal to 10. And then remember that if n times p times 1 minus p is less than 10, then we use binomial distributions to calculate the probabilities. And that is the end of section 9.3. Very quick, but we're doing 5 graded problems there, and it's on determining what type of test you can use and what information that you need.